So good afternoon, everybody. This is the closing ceremony of the UK-RAS Summer Showcase. My name is Rob Richardson, Professor of Robotics University of Leeds, and also the Chair of the UK-RAS Network. So wow, what an amazing few months. So starting in May, going through all the way to now, and as I'm sure many of you know, it's been a really amazing time with lots of different events. We've been looking to really engage online and do things online that we just couldn't do any other way. And I think personally, I feel it's just gone really, really well. I've seen things, I've learned things, I've done things that I think I hadn't even thought of before. So yeah, wow. So just some highlights. Let's have a think about what we've been doing. So over the last few months, over 1,000 attendees to our events. So that's really good. Over 5,000 people watching YouTube content we've created and we've done. So I think we've really been able to engage with different people in different ways that haven't really thought about things before. Some of the things that we've done so many things, I won't have a chance, unfortunately, to talk about all the things that we've been doing, but just some highlights of what we're up to. So we've had the Early Career and PhD conference. That's been running for a few years now. Every year, I'm amazed how much more advanced we're getting with things, how much more exciting some of this technology is. So that was really amazing. We've had workshops on things like leg robots. So leg robots, I think in the UK, we've really come on the last few years. I'm thinking where we were, say, 5 years ago in leg robots in terms of kind of four-legged quadruped robots. Not an awful lot going on, but nowadays there's such amazing research. I think it's great to connect between what we're doing and industry, and that was a really good thing. Workshops on planning, perceiving, moving. This, of course, is really fundamental robotics, being able to explain more of the algorithmic side of things. That was amazing. Another workshop on soft robotics for industry, another opportunity really to connect our really world-class fundamental research to industry and help them to understand, because there's loads of excitement around soft robotics. But that workshop was great to help them understand what they could do with it, what's all the hype, what's the reality, what's the things that they can do. That was great. We did have some events which were more a little bit off technical content, things like ethical black box and human robot dialogue. That was amazing to think about the ethics of what we're doing and how we can interact with that. We, of course, have joined with the Hamlin Symposium over the last many years. And again, really, truly world-class event, run really well this year, so that went really well. And this year, for the first time, we had Robot Lab Live. This was an event where we had multiple labs across the UK, all streaming live demonstrations, and you can flick between them. And this was the first time we'd run it, and we weren't quite sure how it was going to go, but personally, I found it amazing. You could click between different labs, see things that are going on. And my overriding thought when I was watching these things was, wow, that's actually really happening. There's something about the connection between things that are really happening. Watching YouTube videos is fine, but knowing that at that point in time, there's a lab somewhere in the UK that's running this demonstration and it's real, it's not doctored in any way, it's actually really happening. That was just amazing. Again, we've run challenges. These are challenges where people put technical content together and show stuff. The challenges in manufacturing, in medical robotics for contagious diseases, and also in surgical robotics. So these have gone really well again and truly demonstrating the capability across the UK. And also this year, we've had some white papers, again, 2 more white papers released. One on preparing the workforce for 2030, looking at skills and education. So we're very aware that we want to be able to, educate, train people of the future. This white paper looks at that, explores that. And the other one, which was updated this year, was surgical robotics. So we had one a few years ago. Things have moved a long way in the last few years. And this was an update of that surgical robotics paper. So yeah, loads of things going on. I think it's been really good. So today we're really just going to close off what we're doing. And we've got a couple of keynotes, which will be fantastic. And we're also going to announce network awards. So the first time we've done this, we've done some awards we'll come on to later on to award people who have done really exciting, good things in the UK. So without further ado, I shall go across to our first keynote. This will be in robotics from Professor Samia Nefti-Meziani from the University of Salford. So across to Samia. And I should say we will have hopefully a few minutes at the end for questions and answers. And of course, please do type things in the chat if you have any questions as we go through things.
Excellent. Okay, thank you. I think I've got now the slides sorted. Good afternoon, everyone. Thank you for the invitation first. It's a pleasure to me to be here to talk about affordable technology for cross-sector industry, and also how I see from my perspective as an academic, give my perspective as an academic and entrepreneur, where I see the robotics really in the future going. Before I start my presentation, as I said, then I'm professor at Salford, and I'm also leading the development of newly North of England Robotics Innovation Centre, co-funded both by EU and UK Research England. And the idea is to build the cross-sector technologies in robotics. This is the first in the UK, and I'm also coordinator of a co-director of the EPSRC hub in robotics and AI for future space technologies, and the founder of the National Robotics Network alongside, it was in 2013, alongside funded with Salford and NDA. Then I wanted to start really showing you these slides because it's really very important to see why I see the future really will be basically cross-sectorial technology. Then the focus, as you could see from these slides, which I have, I'm showing now, those 4 photographs, coming from, you have different sectors. When you look at the focus of the center, which is in my center since 25 years, was mainly to design affordable smart system machines which can interact and collaborate safely with humans, and a different level of autonomy. So then in my center, I have been looking at how to make machines smart, which can not be just dedicated for one purpose, but ideally, if it could be reconfigurable to meet different tasks from different sectors and so on. Then in the center, we have been interested in undertaking this research rather at component level rather than a system level. And you will see in a minute why it's very important. Then we can see that a reconfigurable system quickly can tackle emerging challenges and the needs of the industry. I will show you in a minute the different type of end users who would require and have basically articulated clearly their need for this type of technology. Then the next slide will show you the different cross-sector technology that we have been developing, but I will just go very quickly on those. But first, let me show you the reason why, as I said, it's important to go through, to talk about cross-sector technologies. You can see as I said, in those, when you look at these pictures, which represent different sectors, food, space, construction, nuclear, and I have carefully selected those sectors because they are the ones that have been funded quite heavily in the UK. One of the main component or the main common problem that these different sectors are facing is handling and automation of the task. For example, in material handling and logistics sector, there is requirement of one handling system that could be used for packaging, construction material movement from place to place, storage, retrieval of parts, without having to change end effector. Then you look at the handling system, it's a technology which can go across all the sectors. Similarly, in space, for example, moving orbital debris using robotics arm in order to reduce risk for smaller debris generation will require the use of dexterous nozzle handling system, which prior knowledge about the object is almost absent. And that's why we've got to think carefully about the use, for example, of vision system in that case. We have as well in the third, another interesting sector where the handling system is required is food, with the UK manufacturing is by far the largest manufacturing sector. However, despite its huge size, the food industry is not particularly technologically advanced when you think about it, and uses very high level of manual labor. Then the photograph here is not uncommon really for of food factories throughout the world. Then this task is already performed manually, and as end effector do not exist capable of grasping them without having to change all the time the gripper. Then another sector which shares the same challenges is nuclear, where waste handling still as a key as a key challenge. Now, I'm just giving an example of the different automation system machinery that we have developed over the years. And, you know, the reason why I have chosen those ones is because it shows how simple they could be. But yet, it's hard to think about the solution. And the reason why I'm doing that is that most of the cost is usually the biggest problem. And us as academics, we have to factor this as a key problem. That when it's good to design sophisticated technologies with very expensive, you know, technologies, but it's very hard to, you know, to design reliable technologies with a very low cost, in very low cost way. And I think that's really important. Then you could see we have developed several machinery, and we've got as well a different, as far as handling system, we have designed different end effector. And as I said, another one of the affordable, for example, automation solution here that we have developed is for full product, which can vary enormously, but you have to have dedicated many grippers for different type of products. This is not the solution, or at least represent a very challenging problem for us as an academic. Something that we have then, personally, my team have been really looking the last decade, and I coordinated a big program, the first I would say in manufacturing, as you know, involving the design of end effectors, but there are special end effectors, there are cross-sectoral end effectors, and this is quite a complicated problem to address. Then I'm giving these, just here, I'm showing a gripper which can be used without the need of vision system. And what is all about is, when you look at the company's art, is all about productivity. Ideally, what we want is to use the same gripper with every single task for different sectors without having to change or to worry about changing it all the time, because that is, in terms of productivity, will not be interested. But also we have to think about the design, because the cost is absolutely paramount importance. Then having a gripper which can blindly, let's say, grasp without letting an object slip, without any type of shape, any type of form, any type of payload, is absolutely a winner for industry. Then this is one example, the first prototype. I'm pleased to say this prototype has been then, we have developed a 45 kilogram version of this gripper, which was part of the 8.5 million integrated innovation nuclear decommissioning competition led by Jacobs and funded by NDA, Innovate UK and BASE, which was part of the technology selected to pass to the third stage. And I'm very pleased to see that this gripper has been, and it's the same gripper that you have seen earlier, will be basically tested on the Salford side by 2022. Then you can see, then this gripper can handle all type of object, including the ball you can see at the back, okay, which was a key problem, especially when you put this in nuclear site. It's important that you don't have to worry about to change the, you know, gripper for any object. Then that's exactly the technology that they wanted to have. I will skip, I'm afraid, these. Then the same version of the same gripper is being deployed now as part of the demonstration, which shows simulated test bed of satellite equipped with a robotics arm, as you could see, with in our first space hub. Then this gripper technology can autonomously and surely grasp a nozzle of this AKM apogee to pull toward the satellite body without the need for an RGP camera. That's really important. You have a two-fingered, the three-fingered version. Another area which is really important, we talked about soft robotics earlier, you mentioned soft robotics is a key area, and the problem is it faces a lot of challenges which needs to be addressed. Why it's important? Because now we want to move from really hard rigid robotics system to really a soft, safe, ideally. But there are, as I said, a lot of challenges need to be addressed. And I think we have been really active in, in designing systems at the component level, why you need to sort out actuators before thinking about robots. And that's what we have been doing. And now we, as part of that, a different technology merged, because we are in discussion with using these soft robotics in manufacturing for maintenance and also assembly. And we have also started discussion to take this further with the hospital. Then we have another here, as you could see, the same technology which is come from the soft robotics is we are deploying it for another application, soft actuator for sensors for astronauts. Then I would skip these because I'm cautious about the time. We have then developed a prototype here for an astronaut, a glove. Then it's wearable and forced augmentation glove using pneumatic muscles. Then it will assist grasping manipulation of objects held by the astronaut's hand. And the accuracy of these actuators will be highly basically depend on the sensing technology, which we have here developed a new type of sensing technology for this basically glove. But the same, I'm not sure if you can see here, it looks like it doesn't, but I will skip the slide. Just then another technology, which is cognitive platform for intelligent perception. Then it was part of the Gamma program. And this is a platform is endowed with high cognitive capability. It has been used for in different sectors. It was for in particular with aerospace, and after in defense with MOD. Now, what we have been using now is part of Innovate UK. The same technology is deployed to build the ACS. And my group is building the ACS, which is this cognitive platform, which is used to connect basically the Westfield autonomous sports cars on the in platooning formation from here Stockport to Manchester Airport. Then the trials will be in August. Then it's a real system now, which is being deployed in a real application. Now, without losing sight about the digital twin, it's a very important part. I know you heard all about digital twin with actually how important with the robotics, with cyber physical system that RGP has been working on. The framework that they have developed. Why it's important, because you could see, we call it in the past, we used to call it simulation, but it's more than that now. We are looking at a framework which basically reconcile the cyber physical world with a platform, robotics platform. Now, I wanted just to talk about how important the cross-sector technology NRN has been doing a lot of work on this, and I'm pleased to say that they have issued the first roadmap now in this area. What we have been really working on establishing the common need, establishing the technology baseline with end users, and also the technology development, and what are the key areas of the technology we need to focus on. Then one of the things I would like to say is that we have to certainly to think about the cross-sector robotics. Then traditionally we have been really focusing on robustness, but I think we need to rethink completely the way that we are designing robotic system. I would say we need to think about the reconfigurability and how important the ability to design a system which can continue to functioning in presence of internal, external challenges without fundamental change of the original system. And those are basically the key challenges that we have to develop. Now, here are the set. I'm pleased to say that my research on cross-sector robotics has been funded recently. As you could see, it's going to be it's co-funded by Research England and also the EU. We managed to secure £18 million on the North of England Robotics Innovation Centre, which will focus on different sectors and also on cross-sector technology. I'm also very pleased to let you know that the UK now is investing in basically a smart automation, smart machines, because it's absolutely vital for industry. And we are pleased to say that we are part, and certainly part of this MP initiative, which is about establishing and delivering capability and activity on behalf of the advanced machinery sector. And that when I say machinery sector, is the entire supply chain. When we think about robot, we don't think only about actually we have to think about the different components, and that's absolutely vital for the UK economy. This is basically following that limited. We just heard last week that we won the MP initiative, which is Strengthening Places in partnership. There's a University of Leeds partnering in that as well. Then the MP stands for Advanced Machinery Productivity, and we will be for the first time looking at how to really develop smart machines. And this is extremely good news for the UK. And without, then those are the partners and the industries who are behind this initiative. Then I would say that to finish off, and I'm sure maybe Anna will talk more about this, to conclude my talk, I would like to say that I'm very pleased as well to show that the direction of the research that we have been, at least my team has been taking how many years and decades, and also the National Robotics Network is now aligned with the RGP aspiration, which is about really building this cyber physical fabric, which is more about, as I said, creating and also more importantly, reconciling really the virtual world with the physical smart machine world. These have to basically we talk about the need of common interfaces, common standards, but also the digital glue, which is really important. You can't do that if we don't start really thinking from now how to build this next generation of common technology or cross-sector technology. Is by only doing that we could have this coalition or the end users who want to work together to build and invest in this technology. Thank you for your attention, and that concludes basically my talk. Thank you.
Fantastic, thanks, Samia, that was amazing. So yeah, so if you have any questions, please do type them in the chat. We'll hopefully have a minute or two later on for some conversation, but please do type in the chat, that would be fantastic. Okay, so I'm delighted to announce our second keynote speaker, who's going to talk about shaping the opportunity of RAS from a UKRI perspective, to Dr. Angus-Smyth from UKRI. Across to you, thank you.
Hello everyone, I'm just going to do that awkward moment where you try to share your screen at the same time and accidentally show your emails or something. So, can you see a presentation or something less interesting? Samia, thumbs up? Super, thank you. So I'm gonna try and be relatively brief. I'm very aware it's Friday afternoon and you probably all have Zoom face. Zoom face is a thing, right? That's a terminology, I think. I'm going to talk to you about, I think, two key things today. Where we are, I think we are now as UKRI, EPSRC, and where I think we want to try to get to. And in doing the second bit, I'm going to warn you a little bit of that's about posing the challenge back to you or throwing down a gauntlet, not an astronaut glove like Samia, but a little bit of a challenge and how do we do some of the thinking about what comes next together. Okay, so firstly, I thought it was useful just to talk about the kind of breadth of support that we already have in our portfolio for robotics and autonomous systems research. And I think the really interesting way to do that is to think about it in terms of both the foundational and applied ways of thinking about robotics and autonomous systems. And in Samia's talk, she talked very much about the research areas, the application sectors, and also the need to think about cross-sectoral working in robotics and autonomous systems. And I think we see a lot of that across our portfolio in quite a rich and varied way. Quite often, I use this slide, and I'm not going to explain to you, teach my grind to suck eggs about all of the breadth of robotics and autonomous systems in the UK to this audience today, but I think it is really useful with lots of stakeholders to be able to talk about actually the breadth of the kinds of applications we see from fundamental research, the kinds of transformational technologies that we see coming out of the work that you all do within our research portfolio, and the need to be able to talk about that both in terms of the foundational research, but also the places that change is being driven. Because in the end, a lot of people that I talk to who aren't you people on the call today tend to assume, and I'm sure you come across this all the time, that the robots in films are real, and that's all done. You can buy it in a shop. But actually, a lot of what I try to do, as I think you probably do, is talk about actually the key foundational research that we need in order to kind of drive that vision forwards. So, at the moment, I think the kind of interesting thing to me is about the richness and diversity of the portfolio that we currently have in terms of robotics and autonomous systems. So we support research activities through lots of our bottom-up routes. We have quite a rich and diverse responsive mode portfolio that comes through across the portfolio, across the organisation, across EPSRC that relates to robotics and autonomous systems, whether it's some of the application work that Samia talked about, or some of the much more foundational kind of computing or control systems work at the other end of perhaps the spectrum. And I think the really interesting thing is we have that basic portfolio. We also have, I think, a really strong portfolio of programme grants. So those are large critical mass investments. And they, many of you will know about these, or some of you on the call, in fact, lead them, sit across the UK and focus on a number of key topics. And I think it's actually really notable that there are so many of these big strategic investments, because I think that reflects how important and valuable the broader research community sees this area to be throughout peer review. Also in our portfolio, I think the role of skills investments, so the CDTs, of which I'm sure many of you are very aware, I think are a key element of what's being driven forward in terms of robotics and autonomous systems, both in terms of research, but also in terms of the broader workforce, and that touches into the white paper that Rob talked about earlier. But the two investments I just wanted to briefly touch on, other than, of course, the very important UK-RAS network, sorry for forgetting the plug there, the two investments I wanted to pick up on particularly are the ISCF investment, which many of you will know is 4 hubs in extreme environments, one of which Samia talked about already. And the other one is a Trustworthy Autonomous Systems Programme, which is a hub and nodes activity which involves about 18 institutions and 100 project partners. And the reason I wanted to pick up on those particularly is not because I don't think the other ones are important and interesting, but because these two have arisen from us making the case for additional investment in robotics and autonomous systems over the last few years. So my role has changed over the about decade I've worked at EPSRC now, from thinking about these kinds of conversations and how do we invest, to also having to essentially write the really big grant proposal to get the money for you to write the grant proposals. So I think there's something interesting for me that I wanted to convey about the fact that we have been quite successful in this space in making those arguments, because that means that others buy into the importance of this area. So I think what the aim of my team is, apologies for the excessively animated slide at this point, but is really thinking about that opportunity. So I think there's quite a high political profile of both robotics and autonomous systems and AI, and the continuum between those things. Don't get me wrong, it's a complex landscape and I could draw many Venn diagrams, but there is a high political profile of them. And I think the interesting thing that my team tries to do, and we were only set up a couple of years ago essentially to do this, is take that political profile and use that as an opportunity for the research innovation community. And what I mean by that is really think about how do we take that profile and advocate for the need for research and innovation investment in order to be able to deliver on the exciting promise that perhaps politician colleagues or industry colleagues might see in robotics and autonomous systems. And we really do that by trying to understand the landscape. So you'll have met lots of my colleagues. We try to understand the gaps, the opportunities, the barriers, and what we might need to be able to do to overcome those, working in partnership with you. But we also spend a lot of time building and consolidating mutually beneficial relationships. And I know that sounds like one of those slightly naff terms, but actually I think that's the core part of what we do is working with UK-RAS, with the RGP, with yourselves on this call, with lots of stakeholder groups, with government, to try to think about how do we advocate for the importance of RAS? How do we really realise the opportunity of the high political profile by collaborating together? So that's where the challenge bit starts to come in, rather than simply the where are we now bit, which is my first couple of slides, because I think in order to be able to really maximise that political profile, turn it into an opportunity for all of us, that has a role for probably everybody in this call and lots of people that we all know. So just to move it on to a forward look, I'm going to say something which might make you all roll your eyes, but it is that, I say lots of those kinds of things, I'm aware of this, don't worry, but I would really encourage you to have a look at some of the current government strategic pieces around research and innovation. So firstly, the government's recently published very exciting innovation strategy brings out robotics and smart machines as one of its 7 key technology families. Right? That says that there are colleagues in the government who've been influenced by the RGP, Samia and colleagues, and Rob and others, to really prioritise the importance of robotics and autonomous systems. There's also things like the integrated review, and that is essentially a review of defence research and innovation across UK government. And that brings across quite a lot, again, of really interesting questions about autonomy, about control systems, about decision-making systems, and the need to build those kinds of sovereign capabilities in the UK. And whilst you might look at those and think, well, Anna, this isn't really relevant to me in my research, I think it is, because that is what the shape of this opportunity looks like. It's that profile that I think robotics and autonomous systems has at the moment in a political context that together, I think we could do something to really build upon. What we've been doing, because we like to have things in the proverbial drawer under the desk, in the back pocket, to make sure that we are ready to maximise those opportunities, to essentially seek funding or use funding if it's available to us, because that's what we do. We've been really thinking about our understanding of the landscape and those opportunities and gaps, and the kind of slightly simplistic, I admit, blue diagram on the side of this screen for me sets out the kind of 4 key areas of the way I would articulate a coherent need to support robotics and autonomous systems in the UK. And that has to be about a combination of foundational research capabilities, including the kind of hardware, the systems, the energy systems, the materials, but also the control systems, the autonomy, the intelligence, the verification, the robustness that we talked about before, and that reconfigurability argument that sits across the two. It then needs to have a piece about the vertical. So I think very much in terms of the horizontal foundationals and the vertical sectors, and thinking about actually how do we move along that continuum and how do we do some of the cross-sectoral pieces that Samia talked about earlier. And I think that's where working in partnership across UKRI is going to be really valuable to us, working with Innovate UK and other colleagues to do so. And then the final 2 pieces are the piece that I think is really important around skills in this area, and how do we make sure we have the leaders of today and of tomorrow, to use one of those kinds of trite phrases, but actually the key workforce that we need in the UK. And as Samia started to mention already, the key digital and physical infrastructures that we need in order to test and to validate and to collaborate, oh my goodness, my adult words are running out on Friday, and to deploy these systems going forward into the future. So just to leave you, I think, with maybe a question. So it's a question that I will leave as a rhetorical one, but it's how can we work together? Because I think, my team and I do a lot of work to try to advocate for the importance of this area. Lots of colleagues on this call do that advocacy piece, but I would really encourage you to think about how do we do some of that together? How can we continue to make the case for all the routes that we can think about for the importance of RAS research, and the fact that we're really good at it in the UK, and the fact that those robots in films aren't things you can buy in a shop without it. I know it sounds flippant, I apologise, but I think we need to remember that that's where some people are as key stakeholders in this space. And I think for me, there are 2 parts to that. One of them is about that advocacy routes piece and what we can all do. And the other one is about evidence and how we evidence the benefit of investment, what's come out of things in the past. I know it can be really annoying when we ask you about comms stories. I'm not even going to mention REF, I know I just did, but I don't really wish to. But there is a really important thing that comes out of stories about impact, which is actually that it tells a really compelling piece to people one needs to convince about the importance of investing in some of these areas over lots of other very important areas that equally exist in the landscape. So I think I would leave it there in terms of here are the contacts of some of my colleagues. Do get in touch with us and talk to us. But I think I would really appreciate your help and your collaboration in how we might work together to think about the future of robotics in the UK. Because I think with the spending review coming up, we all assume there's a really timely opportunity to do so. Okay, I will stop at that point and hopefully we'll have a little bit of time for questions, Rob.
Yes, thank you. Yes, amazing talks. Looking at the questions now, there are no direct questions here. So maybe the thing to do is please, if you have any questions, type them into the question and answer chat. I think maybe from my point of view, it'd be good to summarise what I've heard today. I mean, I think definitely cross-sectoral sounds very important. The idea of technologies that can link and do other multiple tasks. And the idea of collaborating. So we talk about a lot of these things and some amazing sort of jigsaws of things. How can these things connect together to be more powerful? I guess a really good point from Anna in terms of how can we create the knowledge in the background that can support the investment. So I think it's very easy for us to take for granted. we're being effectively fed with this wonderful resource of money, we can do things, but how can we provide the evidence that really helps and makes her case it's much better to be able to do things? So on that note, I say please do drop any questions you have in the question and answer session, and we'll move on from there. So thanks again for 2 amazing speeches. Fantastic. Thank you. So the next thing I want to talk about is a new thing we're doing this year, which is the Network Awards. So what we wanted to do is we wanted to be able to recognise those who are making really strong contributions to the UK. So people doing amazing work, but we wanted to kind of just have a think about, okay, can we somehow recognise individuals that are doing really amazing things? So we've got this idea of having Network Awards, and across 4 categories. So today we'll announce the winners of these categories, and of course we'll have a very brief presentation from the winners. So the first one is our Rising Star Award. This is all about someone who's really just starting their career, just really starting to get going and making a really great impact in doing that. So the first person I'd like to announce the winner is Kai Yuan from the University of Edinburgh. So congratulations to you. And do you want to say a few words or a few minutes about what you've been up to?
Hi, Robert. Thank you very much for this award. I'm very excited and receiving this award. So to me, I'm supervised by Dr. Jibali, who I would like to thank very much for giving this opportunity and his continued support. To myself, I'm a PhD student at the University of Edinburgh with the Edinburgh Centre for Robotics, which is one of the CDTs that Anna just mentioned. And my research is about realizing embodied agents in robot applications. And this is basically done by combining classical control methods with gradient-free methods. And the aim is to achieve intelligent robotics behavior. So the next 5 minutes, I'll give you a brief overview about my research. If my slide goes to the next one. Here we go. So first and foremost, what you have to do is you need to, oh, actually, no, I think I skipped this slide. Okay, anyway, so what you have to do is you have to guarantee that whatever motions you put on the robots are actually stable. And this is still done with control and optimization, so the classic ways where you have stability and robustness guarantees. And 2 of the key contributions that we have actually done are providing a improved formulation for model predictive control of legged robots. And then using that controller, we provide a method to automatically tune the parameters on these robots. This method we call alternating Bayesian optimization. So on top here, what you can see here is we use this model predictive control MPC scheme to make Valkyrie, which is a robot designed by NASA, locomote over uneven terrain. So the robot doesn't know that there's uneven terrain, and the robustness of this inclination is provided by our improved formulation. And down here, you can see what happens if our automatic parameter tuning scheme is working. So in the initial iteration, nothing is going on. And the robot falls over after 1 step. After 1 iteration, it's a bit better, but only after 3, you can see that it walks all the way to the ends, but there's still a bit of jittering. And after 4 iterations, it fully converges. And actually, the parameter set is better than that I could tune as a human by hand. Some of the robust behaviors you can also see is here one-legged balance. So this is, of course, in simulation, where we drop 5-kilogram boxes on Valkyrie, and she's still able to balance. Sorry. And what you can see here is basically Jing, which is a quadruped robot, being pushed, and basically it recovers from a fall. So maybe that was a bit too quick, so I'll just play it again. And the high-level control, it's provided by deep reinforcement learning, but the low-level control is done with very classical control. Then talking about deep reinforcement learning, which is the major part of my PhD, we can, with the advent of deep reinforcement learning, a whole new door opened, which is we can get intelligent motions by only specifying a high-level reward. And the idea here is that we tell the robot what to do. In this case, it's walk forward with a certain velocity, and then just let the robot interact with the environment and learn how to actually achieve that reward. So you can see here quadruped locomotion, quadruped fall recovery, which is from a fallen position, just stand up. Here you can see how a dual arm cooperation is done. So with the left arm, we are actually generating clearance, and with the right arm, once there's enough clearance, we are going to grasp it. So what you can do with deep reinforcement learning is, of course, you can train a policy and then directly put it on the robot, as you have seen in the previous slide. But an alternative way, which we've proposed, is that you can also reverse engineer this AI policy into a controller that does exactly the same thing as the AI policy, but you have the transparency and the stability guarantees that you have from classical controllers. And we have demonstrated one way of doing so, and we've trained a deep reinforcement learning algorithm to make a humanoid recover from pushes. So basically, Valkyrie is being pushed from the back or from the front, and then she just learns how to balance basically the same way as we humans would do. So for example, the step strategy, if I would push you very hard from the back, you would take a step in order to counteract that disturbance. And it turns out that the deep reinforcement learning agent is learning a minimum jerk optimization formulation. So we formulate this as a minimum jerk problem, and we put it into a model predictive control scheme. And in this paper, we basically showed that this is exactly what both the AI policy and surprisingly also humans do. So we found it a very cool new way to actually use deep reinforcement learning policies and also basically bypass the stability concern. Another thing that you can do with reinforcement learning is combining multiple experts. So what we call the multi-expert learning architecture. And the idea is that we would like to use multiple experts and basically use them whenever appropriate and generate new adaptive behaviors and also achieve versatile skills. So what you can see here is that Jaying, which is this quadruped, has two experts. So the experts are fall recovery and trotting. And then using our multi-expert learning architecture, the robot learns new skills. So basically what you can see here is that the skills are smoothly transitioning, and also basically after standing up, it's able to basically walk and then follow a certain steer command. And for example, here you see it's being pushed. It concentrates on standing up. Once it stands up, it immediately switches to the locomotion mode. Just to give you an idea of what motions you can learn from just fall recovery and locomotion. So you can learn how to, for example, follow this ball here. So dynamic steering on the left and to the right. You can learn simultaneously to steer and trot, that you can see here. So it's basically following this green ball, which is in a zigzag. You can, of course, also modulate the velocities. And most importantly, what our algorithm is actually able to do, it's able to work with unseen environments. So here, for example, it has never seen how it behaves when it falls off a cliff, but as you may have just seen, it's falling off the cliff, and basically immediately it's able to stand up again and basically continue its mission. And then just lastly, some ongoing work that I'm doing right now, which is now I would like to see how humans are actually doing motor control and try to adapt that to robotics and generate fully autonomous behaviors. And this is done by mimicking how human motor control is done in humans. So this is 60 years worth of research from neuroscience. There are a lot of principles that have been discovered in the past 60 years, and we're basically applying those principles to robotics. And as you can see here, the algorithm that we came up with that follows these principles is able to pick up a box, deliver it at a table, then approach a door, manipulate such that the door opens with this button, and then finally going to the goal. With that, I would like to thank you for your attention. And if you have any questions, please feel free to email me or my supervisor at this email address. Thank you very much.
Fantastic, amazing, really amazing work. So please do type in questions in the Q&A, or as was mentioned, drop an email afterwards. I think it's really exciting. I think to see the actual kind of way it's evolving and dynamicing, and the job of the person with the stick pushing the robot over looks great fun. So there must be some kind of sport in terms of pushing robots over. That's great. No, fantastic. Thanks for that. So I'm going to go on to the next award now. So this was the Early Career Award. So I guess it's slightly more established. So someone who's now in a sort of a permanent role, who's made a great start on that. And I'm very pleased to announce that the award is going to Dr. Chengzu Zhou from the University of Leeds. So well done to you. And I should also actually mention well done to all the people who entered. They were all amazing entries across all the categories. But yeah, across to Chengzu, please do let us know what you're up to.
First of all, thank you very much for this honor and for the opportunity to present my recent work here. Hi, my name is Chengzu Zhou. I'm a lecturer in mobile robotics at the Real Robotics Lab of the University of Leeds. As shown in the title today, I would like to talk about my work in LEGO robotics and those LEGO robots that I have been walking my career path together with in the past years. All right, so first, a bit of myself. I joined the University of Leeds as a lecturer in mobile robotics in 2019. I'm currently leading research in LEGO robotics at the Real Robotics Lab in the School of Mechanical Engineering. In the past 2 years, I have been successfully awarded several research projects in LEGO robotics, including a Teleman project, which aims to use teleoperated Lego robots for hazardous tasks, and the Workbench project to investigate humanoid robots' locomotion performance in realistic conditions, as well as UK-RI task node in verifiability to study the trustworthiness of Lego robots in practical applications, and the MP Innovation Initiative to develop dynamic smart machine for manufacturing. Last year, together with colleagues from Oxford, Edinburgh, and UCL, we have co-founded the UK-RAS Strategic Task Group in Lego Robotics. We have organized a series of activities to promote Lego robotics research in the UK, including workshops in major robotic conferences, summer school for PhD students, etc., etc. We are also preparing a white paper on Lego robotics at the moment. Early this year, as a team, the Real Robotics Lab has won the Best Design Award in the UK-RAS Medical Robotics Challenge, where we have used quadruped robots and modified to for public disinfection against the COVID-19 at the Leeds Airport and the City Center, Leeds City Center. So before Leeds, I was a PhD student and a postdoc at the Italian Institute of Technology, IT. My work in dynamic working and balancing control of humanoid robots has contributed to the success of several EU robotics projects. On the bottom, they are part of the Lego robots I have been working with in the past year. Yes, from right, there are Walkman, Centauro, Coleman, developed by IT, and also Animal, like Cargo, Alingo, and A1 quadruped robots we have at the Real Robotics Lab. So my work mainly falls into three categories in Lego robotics: mechanical design and development of Lego robots, and locomotion control of Lego robots in real-world scenarios, and increase in balancing capabilities of Lego robots under dynamic disturbances. My research aims at enhancing motion capabilities for Lego robots to achieve more agile and versatile motor skills, to realize safer interaction with the environment and with the robot with humans and between Lego robots, and to obtain robust performance over time. All this leads to my final research goal of deploying Lego robots to the real world to improve our life quality and safety. So due to the time limit, I would like to highlight our most recent project, Teleman, which is investigating telepresence using Lego manipulator for tasks in hazardous environment. As you can see, the system consists of a Lego robot, quadruped robot like Cargo, and modified robotic arm on top of it. And also the system has 3D stereo cameras, as well as a human operator with a wearable inertial-based motion capture bodysuit and a virtual reality headset. So in this video, you can see the human operator is remotely operating the Lego manipulator for a bomb disposal demo. He controls the robot to move firstly close to the bomb, which he needs to open a box to get access to. After unplug the bomb while he manages to walk the Teleman robot away. So there are still minor issues such as bodysuit feedback drifting, communication delays, etc., etc. But the whole system shows great potential to relieve humans from dangerous tasks. For my future work, I will devote myself to improving motor intelligence for Lego robots. For instance, we can combine advantages of different locomotion styles to achieve best performance on complex terrain. And the quadruped robot needs manipulators to open wider possibilities. However, their whole body motions need to be wisely coordinated. We also need humans in the loop for some hazardous tasks where mature immersive existent technologies are needed. Also, the rapidly evolving AI, which is becoming more and more important to improve LEGO robots' perception and decision capabilities to realize more complex LEGO motor skills. All in all, I'm expecting to see more and more LEGO robots coming into our lives to solve the real-world challenges in different sectors. Last but not least, I would like to take this opportunity to thank my team, collaborators, and founders for their invaluable support in the past years. Thank you very much.
Fantastic, thank you. Yeah, amazing talk, and again, congratulations. Great piece of work there, really good. Let's go on to the next award then. So the next award was all about impact. So of course, we really need to make sure that we do robotics for real world impact. So we're looking for, again, great applicants for this award. But I'm very pleased to announce the winner was the COBRA consortium, led by many people. But today to talk about it is Dr. James Kell. So across to you, thank you.
Hi there, Rob. Thank you. Good afternoon, everybody. Yes, my name's James Hyde. I'm representing Rolls-Royce today, but really I'm representing the whole of the COBRA team. So hopefully you'll be able to see my slide. So I can't see anybody from Zoom at the moment, so I'm just going to plow on regardless. And if somebody shouts in my ear, that means that everything's gone bad. But okay, so thank you anyway. Thanks again. It's an honour for me to kind of speak on behalf of the team, really, that you see in front of you there, just to kind of describe some of the things we've been doing from a COBRA project. And I think one of the reasons maybe that this caught the eyes of the judges is perhaps because we're really looking for this to be a cross-sectorial type project, along the same lines as that Samia was just describing, in terms of we're trying to design something that can work for a couple of different particular user scenarios, but also more than that, kind of get the building blocks of that to be applied in a range of different areas too. So we've been collaborating with the range of different people to make COBRA. So this is a project that started in 2018 in January along the ISCF Industrial Strategy Challenge Fund around robotics. But this is one of the ones that was funded by Innovate UK, as it was at the time. So it's just finished actually, kind of March, well actually kind of spilled there into April this year. And from a kind of end user perspective, Rolls-Royce are representing the team, as well as also leading and coordinating the project. We're kind of bringing into user cases in terms of getting into jet engines or getting into civil nuclear reactors to perform some form of inspection or maintenance task. And another end user is UK Atomic Energy Authority, in this case represented by RACE, but they're also with us for the human robot interface. From a hardware and snake robotic software / control perspective, the University of Nottingham were the big leads within that. And in terms of actually doing something useful at the end of the snake, we were brought in an SME called Optech Systems for miniaturizing a laser, which I'll show you in a moment. So there's kind of a couple of different aspects to what COBRA is. One of the biggest things I think we've brought out of the project is a modular snake robotic platform, and that's the thing you see in the left-hand two blue boxes. That's covered by the University of Nottingham. Human robot interface, the kind of green box, that's something that we did with RACE, and that's kind of the laser head that was described by Optech, kind of a bit more of a graphical way of showing the first slide. The thing I haven't mentioned yet is the shape sensing fiber. So I haven't got much time today, but one of the things we are keen to do actually is get more videos of this type of technology out there in the world, and kind of speaking directly to Anna, really, I'm keen to kind of get this type of thing shared. Very happy to kind of be used as case studies and things for the future, based on the fact that this was funded by ISCF. So please do get in touch if you want to know more. But just a bit of a shout out really to the guys in all of the different parts of the project that have made this a reality. So firstly, to the University of Nottingham, as I said, the guys there, David Altor and Dragos Exinte, really basically devised and produced a prototype, a very advanced prototype, I should say, modular snake robot platform, which involves a couple of things. So that they're going to start the wrong way around. So number two is one of the examples of a interchangeable snake robot. So you can see this thing here is only about the size of, in terms of diameter, about the size of a pen. So if you're making some notes, that's the kind of thing that you kind of have as a
Yeah, sorry, James. Can you hear? We can't see a picture. Sorry, we haven't got.
You can't see anything. Okay, that's a shame.
No, I can't see. I can see you, which is great, but I can't see a picture.
Right. How about that?
That's better. That's good.
So you can see me. All right. So there's some blue. So we've described all that stuff. So we're going to kind of go on to the main parts. Thank you for intervening, Rob. I could have been going on for a long time there. But yeah, so this is kind of the main building blocks of the project, really. The snake robot part, of which we've built within the project too, and actually outside of the project we've built more than that. So the actual kind of snake part is this bit here. You see going into a bit of a jet engine, so that we can actually perform some form of task and kind of inspection scenario. The bit that is connected to and actually provides a way of controlling and pulling all those tendons is the thing on the left hand side that we call the universal actuator pack. So that's the big, expensive and highly capable part, but we only need one of those. And the relatively low cost part, which is doing a bit of a disservice, I should say, probably, is the snake part, which we can interchange. And we've got a couple of these things, and one of them has been used in a kind of medical application, which I'm hoping that the University of Nottingham will start to describe in a bit more detail in the coming weeks and months. So from a human-robot perspective, human-robot interface perspective, RACE did a lot of that work. So one of the kind of cool things about this one was that we did some work in a remote control scenario. So the guys in RACE, Andika and Stephen, devised a way of us being able to control the system but from a remote location, which was pretty cool. And that's the thing you see on the first image there on the left hand side. So that's Andika controlling the snake, which he is in Oxford, Oxfordshire, and we're all sat in the university labs in Nottingham and watching the snake be driven around a little test scenario. And it's really difficult to make out without proper big videos, but one of the things I think is really cool about the work that RACE have done is the bit on the right hand side, number 2, which is to do with really kind of a digital twin or a simulator, but also kind of embodying a kind of visual odometry. So this is a way of us being able to simulate where we think the snake is inside the engine, which I think, if you can imagine trying to poke a kind of a wobbly stick inside a jet engine, you're not really going to know where it is unless you know an awful lot about the architecture. So this is something that is really helping us de-skill that type of operation. And of course, it's not necessarily just applicable to robots. You could also apply it to a range of other things too. Of course, when we get to the area of interest that we've inspected previously, probably, we're not just interested in looking at something, we're really keen to actually perform some form of useful task. So that's why we brought in Optech into this consortium, and they've actually devised a way of miniaturizing the beam steering hardware so that we can actually machine metal components, but with this tiny device that is only about 8.5 millimeters across in terms of diameter. So the amount of power that's going through there is relatively big, and it's able to machine kind of metallic parts for things like removing damage or getting rid of corrosion, etc. But we can also pass it through a 10 millimeter hole and perform some form of invasive surgery on a jet engine with it. So it's all pretty cool. If you kind of build all that together, you see this is a kind of very quick, brief video, but you see the kind of snake making its way up to the top of a jet engine and performing some form of inspection. So that's just a cross section of it working in a lab. There's the laser doing its milling, and just kind of a brief kind of glimpse into the fact that we have done it on a real engine a couple of times actually, but we're in the middle of kind of cutting together a really big, good video that shows all of that capability that I've just tried to touch on. But it just, I suppose, befalls to me to kind of thank everybody on behalf of the rest of the consortium, the rest of the people involved. You see those guys listed there: David Dragos, Richard from Rolls-Royce, not mentioned before, but he's somebody that works from our side in the nuclear business. Mike O'Key in Optech, Stephen and Andika in UK-RAS. We've all had a great time doing this work, and I think I'm sure they would agree with me and think we're quite happy to share this in various different platforms. So please do get in touch. Thanks very much.
Thank you. So congratulations again. I know personally how hard it is to get dexterity manipulation in such a very small, slender robot arm. So yeah, a very big achievement, and not to be underestimated how difficult that is. So yeah, well done again. Fantastic. Let's go across to the last award then. So the last award was really looking at those who have contributed to the UK-RAS or UK community in robotics and helping and making things better. And I'm very delighted to announce the winner of this is Gianmarco Pisanelli from the University of Sheffield. Over to you. Congratulations.
Yeah, so first of all, thank you very much for choosing me for this award. This means a lot to me, and I wasn't even expecting it. So yeah, thank you very much. So in this short presentation, I'll try to be very quick in interest of time. I'm just going to cover just a few points. Firstly, who I am, brief introduction about myself, and then the 3 projects that I think gave me the opportunity to win this award, which are the UK-RAS Manufacturing Robotics Challenge 2021, ROSI 2 and 2.5, the CSI Cobalt project, and then in the end, I would like to thank a couple of people that made this all possible. So who am I? I'm Gianmarco Pisanelli. I'm a control and system engineer at the EPSRC, at the Advanced Manufacturing Research Center, specifically the IMG, the Integrated Manufacturing Group, which is owned by the University of Sheffield. I'm responsible for the robotic coil winding cell, which is a picture that you can see on the right. I'm also the project manager of the ROSI 2 project, which I'm going to discuss in a second. And I'm also responsible of expanding the ROS capability within the IMG and EPSRC. So the Manufacturing Robotic Challenge, this was an event that we ran at the Factory 2050 in Sheffield. And it was part of the Robotics Summer Showcase 2021. This event was jointly hosted by the EPSRC and the CSI Cobalt project. As I said, it was held virtually at Factory 2050, and we had 37 participants across 11 countries. The event was run last week from Monday to Wednesday, and we provided one-day training on ROS and safety and security in robotics, specifically collaborative robotics. And then we asked the participants to take part into 2 challenges. You can see what the challenges look like or involved in the GIFs and the pictures on the right. So the first challenge involved was based on the ROSI 2 project, and involved an EWA robot, which is a collaborative robot with 7 degrees of freedom, that was mounted onto a welding table. And there was the ROSI 2 project basically is a simulated environment of the real physical system, but it's also a digital twin. So what we decided to do was to ask the participants to first tackle the challenge virtually. And then because the event was held again virtually, they couldn't be physically at the EPSRC. So we asked them to upload the code to the real robot, given the functionality of the ROSI 2 project, which is a digital twin environment, which allows you to control the simulation and the real robot in the exact same way. What the task involved was an automatic surface sterilization for COVID-19. What it exactly involved was there was a sanitizer gel on the table, and then there was a sponge. And then the participants were requested to pick up this, the gel, spray onto the table, and then put it back in its position, and then select the sponge, and then scrub the table. I have to say that most of the participants did very well in the simulation. When it came to actually uploading the code on the real robot, only a couple of the groups managed to actually perform the real task onto the table. But it's something that was expected because, as I said, they were controlling a robot from anywhere in the world. We had people from Brazil, Canada, Japan. So it was very exciting to see a robot moving when someone was controlling it from across the world. Well, the second challenge was based on the CSI Cobalt project, which again, I'm going to speak about in the next few slides. And this is, again, is a digital twin environment that is mostly focused on safety and security. So the guys at University of York and the University of Sheffield and Sheffield Robotics, they have created this environment that's meant to simulate a PCR sample preparation for COVID tests. And the idea of the task was to have the human and the robot collaborating together to prepare these tasks. And then in the environment, participants had access to 3 or 4 different types of sensors, and they had to create an assurance case explaining which sensor they decided to use for the robot to complete the task in order to ensure the safety of the human. And that's pretty much the second challenge as well. So why did we decide to go over COVID-19 or to shape the challenge around COVID-19? First of all, this challenge was meant to happen in 2020. Obviously, because of the pandemic, this didn't happen. And then subsequently, the event was, we decided to hold the event virtually due to COVID-19. So we decided, why not turn our weakness into a strength? And then we decided to use, shape the event around COVID-19, mostly for 2 reasons. One, to indicate how robots have helped us during the pandemic, but also to show people that it's still basically to represent the novel way of working that the pandemic has shown us, which is this hybrid way of working when some people can work from the office and some people can work from home. I'm sharing here a couple of articles from Forbes and IEEE Explore, where there's a lot of examples how robots have become an essential part of the war against COVID-19. So as I said, the first challenge was based on the ROSI project, specifically on the ROSI 2 project. And why ROSI 2? Obviously, there was a ROSI 1 project initially, which we ran. And the primary objective of the ROSI project was to demonstrate the use of ROS in a vision guided and place operation to illustrate the potential for the platform. The idea around this is that usually ROS is used in research and university, but it's not very welcomed in industries. So what we're trying to do is we're trying to move every ROS projects from lower TRLs to a bit higher TRL so that we can help industry commercialize more products that are based on ROS. There was also a secondary objective on the ROSI demonstrator, which was collect and capture data to improve the performance of the robot through machine learning techniques, specifically reinforcement learning. The ROSI 2 project instead, what we did was we moved the same sort of platform that we created for the ROSI 1 project from an industrial robot to a collaborative robot. This because we wanted to remove the fences and we wanted to have a better interaction with human-robot interactions for human-robot interactions. And we wanted to prove that, again, ROS is safe to use if controlled properly, and it can be adapted to collaborative robotics. These are briefly the objectives of the ROSI 2 project. As I said, we wanted to build a ROS foundation framework for future technology coming from university to be implemented onto collaborative robots. We wanted to create a ROS demonstrator for the EPSRC shop floor and Sheffield Robotics. We also wanted to create a Cougar digital twin that could be integrated with Unity virtual environment, and then expand this environment with augmented reality using the HoloLens 2. We also added a natural speech interface, which allowed us to control the robot, not only via augmented reality, but also by speech. And we created a demonstrator that we want to show to international conference, first of which was meant to be the ERF 2021, but that was again postponed due to COVID. And also we wanted to provide a clear example of how collaborative robotics can be used in an industrial environment. And finally, and most importantly, we wanted to create a foundation platform for the robotic manufacturing challenge that we held in last week in Factory 2050. This is a very brief architecture of how the whole system is work and integrate with each other. I won't dwell into into this, but if people have got questions, feel free to contact me. And then, have I got still time? I can see you, Robert.
I'm sorry, I think we're almost out of time, so very, very briefly, it would be great.
Okay, so ROSI 2 is basically an further expansion of the ROSI 2 project, and we want to better enable the plug and play capabilities of ROSI 2 so that any robot can be just adapted. We can just have adapt the ROSI 2 functionality to any robot in Factory 2050. And then finally, the CSI Cobot is a project run by University of Sheffield, Sheffield Robotics, University of York, Assuring Autonomy International Program. And I mentioned this briefly before, it's about creating safety in a virtual environment and then having a digital twin to improve the safety of robots. And then finally, I would like to thank the other organizers of the UK-RAS Manufacturing Robotic Challenge that made it possible, and the UK-RAS Network for choosing me for this award. And finally, Steve Bowles, Tom Hudson, Lloyd Tinkler, and Chris Craggs, who have a secret meeting to nominate me for this award without me knowing. So yeah, special thanks to them. And yeah, that's it for me.
Fantastic, really great, and congratulations again. So congratulations to all of the winners and all who've done things. So yeah, wow, what a few months of UK robotics. I think we've shown today there's so much going on, so much amazing stuff, and I feel totally inspired by it. So just again to congratulate everyone for their hard work and things. I think everyone's team effort across things. In particular, I wanted to thank those who helped, or I guess those who have organised all the events, or at least led some of the organisation of the main events. So to thank Marianne Knight, who's part of UK-RAS, but in particular to congratulate Dr. Claire Asher, who's really tirelessly pushed forward loads of these things. I'm sure many of you who've been involved in events have been in contact with her, and being able to bring all these things together into a coherent form, ensure that they run smoothly and things has been such an unbelievable, amazing achievement. By far the biggest UK-RAS summer event we've had ever, and I think it's just gone amazingly smooth. So congratulations and thanks to her for making all this amazing stuff run. So it just leaves me to say again, well done to everybody, and let's take a break from robotics we can do over the summer a little bit, have a bit of a holiday. When I see what's going on, I feel really excited and driven to push this forward, and I think the UK has got an amazing chance to be really world-class in so many areas. So let's come back fresh in September, let's move on, and let's make all these things connect together and make UK robotics fantastic. So with that note, I shall say thank you and goodbye.